fond of and have the opportunity to see from my backyard as I'm showing you here the Northern Lights. It's on the bucket list. Seeing the Northern Lights, or the Aurora Borealis in this case. There is an Aurora Australis, but mostly it's the Northern Lights that people want to and are able to chase, to see, to add it to their bucket list experiences of the night sky. As I said, I'm fortunate enough to live in Western Canada here, southern Alberta, where we can see the Northern Lights from time to time right from my backyard. I don't have to chase anywhere. This was, as I record this, a couple of nights ago on October 11th, when we had an all-sky display. It was seen across Western Canada and well down into the northern United States as well. It was one of these great displays, and there was warnings out and that people might be able to see something that night. And indeed, the sky did perform very, very well. And we got a classic display of Northern Lights and also some other odd phenomena. I'll talk a little bit about some of these as we go along as well. This was a case of this anomalous red arc across the southern part of the sky here, along with these green blobs. So I'll talk about some of the other oddities of the Northern Lights as well as we go along. We'll finish off talking about Steve, the infamous Steve. Tonight, the topics are where to go to see the Northern Lights, when to go to see the Northern Lights, what causes them. There's some misconceptions. How to know when to look, where you can get notices and warnings. What to see, the colors. What can you see of the colors of the Northern Lights? What everybody wants to see. They can be elusive. And how to capture the Northern Lights. Very easily done with modern cameras today. And we'll finish off talking about the infamous Steve Aurora, kind of discovered around where I am here in southern Alberta. I'll tell their story in a moment. Well, first of all, where to go to see the Northern Lights? Obviously, you want to go north to see the Northern Lights. Here in Western Canada, we can see them quite often, usually, as this picture shows, low in the northern sky. This was on a June or midsummer night from a lake not far from where I live, where there's the Northern Lights, and also just close to the horizon, some noctilucent clouds as well. We're fortunate we can see them kind of year-round here from where I live. But if you want to increase your chances of seeing the Northern Lights, you want to go to where they're visible most often and are most spectacular when they do appear. Now, that's where I live, in southern Alberta in Western Canada here, about 100 kilometers east of Calgary. And so I can see them off to the north because the main zone where the aurora is seen is this auroral oval, this oval of frequency of where the Northern Lights most often appear. They're not most often seen way in the very high Arctic or at the North Pole. They're centered on this oval around the North Geomagnetic Pole in the high Arctic islands of Canada. So it's around this auroral oval that are our prime aurora tourist destinations. Norway, I'll show you some pictures from Norway. Churchill, Manitoba, where I was going every year until the last couple of years. And then Yellowknife in the Northwest Territories in northern Canada. All spots right along and underneath the auroral oval, where you increase your chances of seeing the Northern Lights on a week or 2 week trip or whatever, with the goal in mind of checking that bucket list item off. Or Alaska. I've not been to Alaska yet, nor Iceland. Friends have gone there and rave about it. A great, incredible scenery at both locations as well, and also prime destinations to see the Northern Lights. So those are destinations on my bucket list to get to see, just to experience the aurora from a different location. So you might want to go up to Alaska, Anchorage and Fairbanks, prime destinations to head to see the Northern Lights and stay within the United States. Here's the auroral oval from Norway. The aurora forms along that band as really kind of a circular band across the sky is often how it starts off, and here it is. From Norway, we're looking north. You can see the Big Dipper. When I go to Norway, or was going to Norway, I was a lecturer on the Hurtigruten ferry ships up and down that ply the Norwegian coast from Bergen up to Kirkenes, and you're above the Arctic Circle and in the auroral zone for about half that trip. And so lots of tourists go on those ships specifically to see the northern lights, in addition to the fantastic coastal scenery along the Norwegian coast as well. So there's the oval stretching across the northern sky. Now here it is seen over North America from space, looking down from space from one of the NASA or the NOAA satellites in this case. You can see that auroral band, the actual aurora, stretching across northern Canada here. And again, at the bottom left is where I live, near Calgary, and there's Churchill. Did a little dot of light on the shore of Hudson's Bay, and Yellowknife, a little bigger dot of light on the shore of Great Slave Lake in Canada's Northwest Territories. Two locations in Canada I go to chase the northern lights, to see them overhead, or in this case, this night they would have seen them to the south. Here's the auroral oval from Churchill, Manitoba. In the middle of winter when we go there at the Churchill Northern Studies Center. I'll show you some other pictures as we go along, but there it is. There's that oval stretching all the way across the sky from east to west and going across the northern sky, or typically coming up right overhead and even into the south, as you can see over to the left picture there, a bit of a faint band of aurora through Orion. And here is the auroral oval 2 nights ago as I record this. Again, look, as the display started, it eventually did fill the whole sky from southern Alberta here. But it started off as this arc of light stretching across sort of 180 degrees of sky from east to west as you're looking north to see the main auroral oval. People much further north up in Yellowknife would have seen it right overhead at that time. So where do you have to go? Well, it's not enough to say just go as far north as possible, because you can go maybe too far north. Or you can wait for the aurora to come to you. And this is a diagram produced by Chris Ratzlaff, a colleague here in Calgary, who is one of the administrators for the Alberta Aurora Chasers Facebook group, and I'll talk more about them towards the end. But this sort of shows you where you can see the aurora on the horizon at various KP planetary index levels. Sort of these are the main indicators for whether there's going to be a bright aurora or not. The KP index goes from 0, nothing, to 1 or 2, where it typically is, up to 9. But typically in the 3 to 5 or 6 range is kind of where you want it to be to begin to have some chance of seeing the northern lights. But at KP, let's see, KP1, there we are, KP1, you're seeing the aurora just on the horizon from central Manitoba, northern Alberta, way up in northern BC. KP1, kind of the lowest level, just as a glow along the horizon. KP2, the aurora is coming down a little bit farther south, going up a little bit higher in the sky, and you're seeing a bit more along the horizon. They're seeing it from Edmonton and Saskatoon now. At KP3, people in Winnipeg, and where I live in southern Alberta, we're seeing aurora as well. But again, just as a glow along the horizon. Nothing terribly exciting, perhaps. But at KP4, things are getting more interesting, more exciting. People are now beginning to see the aurora from just into the northern United States, but from that central area, North Dakota, Minnesota, the Upper Peninsula of Michigan. Those are the prime aurora viewing areas in the lower 48 of the U.S. KP4, they're beginning to see it, but again, maybe just a glow along the horizon. At KP5 now, as it was a couple of nights ago, and it went up to KP6, now people are starting to get kind of excited at the prospects. If the warnings come out that that kind of KP level is imminent in the next few hours, perhaps. Now we're beginning to see the aurora further south into central Minnesota, Montana, and the like, and further down into Wisconsin. KP6, now now we're probably in for a pretty good show, at least in the northern part of the U.S., as we had a few nights ago here. And we're seeing it very prominent in our skies in Western Canada. But it's got to get up pretty high, even to see it from Washington or Oregon, even though their latitude is not terribly different from, say, Minnesota or northern Wisconsin. They're further away from the Earth's north magnetic pole, and so it takes a higher KP to bring the aurora down over the Pacific Northwest in those parts of the world, even though their geographic latitude is not terribly different from places in North Dakota and Minnesota. Those are the prime destinations to visit, to plan a trip if you want to stay in the lower 48 of the U.S. to see the northern lights. But it's got to get up to KP 4, 5, or 6. Now, you do, however, want to see the northern lights as more than just a glow along the horizon. That might be neat, but you really want to see it overhead, as I'll show you in a few pictures now, in a moment here. But now KP1, we're seeing it overhead way up in northern Alberta, KP3 in northern Alberta, central Saskatchewan and Manitoba, KP5, we're seeing the aurora overhead in Winnipeg, Regina, and into Calgary, KP6, southern Alberta. We're seeing it now overhead from where I live, as we did a couple of nights ago. But just into North Dakota and northern Minnesota and the Upper Peninsula of Michigan at KP6. It's got to get up to a very high KP to begin to show a really dramatic display of northern lights much farther south than that in the United States. So KP is one of the main indicators that we look for. You'll see that on spaceweather.com and various apps I'll tell you about. The other one is the BZ or BZ index of magnetic fields coming from the sun. And that should be south or negative, because you can get very high KP, but if the BZ is north, then the magnetic fields of the interplanetary fields coming from the sun don't connect with the Earth's magnetic field, which is pointed north. You need a south-pointing field coming from the sun to connect better with the Earth's magnetic field. So that BZ should be south and as far south as possible. And there are usually charts as well on some of the apps I'll show you where it shows the current BZ, what direction it is, and we want it to be south or looks like it's going to head south in the next few minutes, and it can change from minute to minute, certainly hour to hour during a typical magnetic storm as well. So we suddenly see more aurora in an outburst, in a storm as well. So the BZ index is very important as an indicator as well. Sometimes the warnings go out that we're going to get a high KP that night and it fizzles. We don't get anything because that BZ never went south far enough to really connect with the Earth's magnetic field. But this is what you want to see, however, and this is what you want to chase for. This is what you want to go north for, to get underneath your auroral oval, so you are underneath the aurora. It is overhead. This is from the Norwegian coast, where it's just dancing over the whole sky. This is from Yellowknife, 62 degrees north latitude, prime location underneath the auroral oval, where it's just dancing over the whole sky, and your jaw just drops. You cannot take it all in. It's hard to imagine the sky is capable of doing this. It's just absolutely marvelous. This is a real-time video taken during a display like that, but now looking more at the horizon, but it's coming up right overhead. But this is real-time video. This is not time-lapse. This is not sped up. Cameras are capable of doing this, showing you the actual motion during an active display. And when it gets bright, when that KP picks up and the activity level picks up, it really starts to dance. And you see that fine rippling motion. And you see, with your eyes, these colors, the greens from the oxygen, the pink fringes along the bottom from nitrogen as well. This is what you pay your money to see. This is what you want to chase to see, to get underneath your auroral oval, to increase your chances of a good display over all or part of the sky as well. So that was from Yellowknife a couple of years ago. This was a fabulous night up in Churchill. Same thing. This is a fisheye lens looking up over the whole sky, where just for a few minutes, what was a good display turned spectacular. and just the sky burst open, rippling like that, and these vivid pinks across the sky from nitrogen glowing at the bottom of the auroral curtains. Fabulous display. You definitely chalked it off your bucket list. You see something like that. It's up there with a total eclipse of the sun in terms of wanting to see a 10 on a scale of 10. Here is the aurora to the south now from Churchill, where it's not just overhead or to the north, it's to the south. This is the aurora that they would be seeing in their north from places farther south, up in Winnipeg perhaps. This is to the south here. And now, there is a story that goes out on the news from time to time that you better see the aurora now because it's going away from us. That the Earth's magnetic pole is shifting and moving to the north and taking the aurora away with it and moving it away from being over North America and putting it more over Russia or whatever, that we're not going to see it. Well, don't worry. The Earth's magnetic pole that your compass points to is moving rapidly to the north, as the chart shows here. But that's not where the aurora particles are going to. They're not going to the Earth's magnetic pole. They're going to the Earth's geomagnetic pole. It's different, and it hasn't moved much in decades. It's up in the high Arctic islands of Canada, and that's where the aurora particles are all trying to funnel down into and intercepting the Earth's atmosphere before they can get there, of course, because the Earth gets in the way, and they form that ring of light around the North Geomagnetic Pole. It hasn't moved much in decades. It isn't moving much. For example, where we go in Churchill and attend to Aurora tourists at the Northern Study Center is built on the grounds of the old Churchill rocket range, where they used to launch rockets up in the Aurora, built in the 50s, 60s, and in use into the 80s. Because it was underneath the Aurora, it still is. They're not launching rockets there anymore, but it's still prime location underneath the auroral oval. It hasn't changed much in decades. So don't worry about that. Now, when to go, however, you do want to plan exactly when to go. From where I live, as I said, we can see an all-sky aurora perhaps even in midsummer. This was a few years ago on literally summer solstice night, I think it was, where the sky is bright from where I live at 51 degrees north. You can see perpetual twilight lighting the sky, but the sky is still dark enough that a bright display of aurora shows up, and this was a great night on another one of these KP 6 or 7 nights where we got fair warning that a good display was imminent. This was in July 2020, one of those magical nights when we had the comet Neowise around, and an aurora across the sky as well. Fabulous. So from our latitudes here in southern Western Canada, 49 degrees is our border here, 50 degrees, 51 where I live, and up to 54 or so. We can see a northern lights all year round, even in midsummer. But you do not want to go up to those locations underneath the auroral oval in Alaska or Yellowknife or Iceland or whatever in midsummer. The weather might be very nice and tempting, but you're not going to see the northern lights because the sky doesn't get dark enough. From those kinds of latitudes. You don't have to be above the Arctic Circle. Even at Yellowknife at 62 degrees north, it's not dark enough from essentially April to early August or so. So from Churchill, for example, it's only at 58 degrees north. Prime location underneath the oval because it's the North Geomagnetic Pole is due north of Churchill. And so the auroral oval comes farther south over North America at that longitude, sort of Manitoba and up into Churchill. And so we're only at 58 degrees north, but even so, the sky is not dark enough in summer. It's kind of late August to late April is aurora season in Churchill. And we take people up there at the Northern Studies Center to see the Northern Lights in midwinter. Yes, it's cold in February and March, but that's when the chances of the clearest skies are in midwinter. Right now, at this time of the year, October and November, prime tourist destination to go to Churchill to see the polar bears, which are gathering to migrate out onto the Hudson's Bay ice as the ice freezes up. But it's very cloudy a lot of the times. Even though the aurora might be happening, people aren't seeing it. It's midwinter, true of Churchill, true of a lot of locations in the Arctic. you kind of want to go there in midwinter because that's when the skies are clearest, even though it's minus 30 or something Celsius at Churchill at that time. But nevertheless, people have a great time there, and the displays are fabulous up in Churchill, Manitoba. But you're not going north to see the aurora because the aurora needs cold weather. That's a misconception, that somehow it's the cold weather that generates or is responsible for or is necessary for the aurora to happen. That's not true. The aurora is happening hundreds of kilometers up there, nothing to do with the weather down here on Earth, doesn't affect the weather down here, and the weather down here does not cause the aurora or suppress the aurora in any way. You're just going north in the midwinter to get the clear skies. The long nights as well are an advantage, but it's the clear skies when it's coldest is often when it's clearest from any of those sorts of locations. And here is a fabulous night in March 2016 where the aurora just went crazy in this incredible arc across the sky with these beautiful colors. So that's when we take people up to Churchill. Yellowknife, their prime tourist season is typically January, February, March as well. By April, it's getting too late and too light as well. But September to March is a good season, and I like to go up there in September. Wasn't able to this year or last year, hoping to next year perhaps, but certainly prior to that I was going up each year. And there's a window of time in early September when it's dark enough and getting dark soon enough and dark enough to see the northern lights, but it isn't getting really cold yet, and the skies aren't clouding up. Later on into October and November, it's getting cloudy a lot. But in early September, the weather is usually pretty nice. Still coolish, but not like it'll be in February or March. So that's a prime time to go up to Yellowknife. This was a fabulous display right from downtown Yellowknife, or looking towards downtown Yellowknife from an area called Old Town at Pilot's Monument. And so the aurora is bright enough to see and photograph even from downtown Yellowknife in this case. Fabulous, fabulous night. And out of Yellowknife along what's called the Ingraham Trail, all kinds of lakes, and in early September they're not frozen yet, so you got these great views of the northern lights reflected over the water, the autumn trees and aspens turning color, the Big Dipper there. This was a fabulous night at Prelude Lake a couple of years ago. So it's a favorite location and time to head north. Is that time when you're not in the dead of winter, but it's a narrow window before the clouds really start to roll in. Norway, where I go, is often October, November, and then again February, March or so. Because in Norway, at that longitude on the Earth, the auroral oval is tipped over to our side of the world because the geomagnetic pole is on our part of the world. So to head up to the oval over in the European side of the world, you've got to go right above the Arctic Circle, in this case like 69 degrees north, to get underneath that auroral oval. And yet the temperature is quite mild because of the Gulf Stream, which goes all the way up there. So even though you're going in the middle of the winter, it's not like as cold as it is here in northern North America at that similar latitude. So Norway is a great location. This was a last trip I did a couple of years ago. Panorama along the Norwegian coast. The scenery is just incredible, regardless of whether there's aurora at night or not. And what causes the aurora? This is kind of rife with some misconceptions because there's kind of general arm-waving explanations, and they're kind of inaccurate as well. Sunspots have something to do with it, but not necessarily the cause of the northern lights. And the sunspots are an indicator of the solar activity cycle. When the sun gets more active every 11-ish years or so, we're coming out of the downturn, coming out of the minimum in 2018, 2019 or so, and in the next couple of years and into 2024, 25, we'll head to another peak of solar activity activity level. The last peak was rather low. The couple of peaks before that, early 2000 and early 90s, were very high. We had spectacular displays during those peaks that went quite far south at that time. Some of you may remember seeing them perhaps. And so the activity level of the sun is picking up. But if you go north to the auroral oval, really the sun and the Earth's magnetic field is capable of producing great displays any time during that cycle. You just get increased chances of good activity and good displays with a solar maximum, and we're heading towards that. How high that peak will be in the next couple of years is open to debate. There's various predictions about that. And so it's activity of more sunspots, but also more flares. It's not really sunspots, but it's flares associated, explosions associated with the sun, with sunspots that blow off literally part of the sun's atmosphere into space and blow it our way. And so there's warnings out when there's been a very bright and energetic solar flare on the sun, because it causes these coronal mass ejections, these kind of bubbles of the sun's atmosphere blowing off into space, as you see here, taken from the solar, I think the SOHO satellite in this, oh no, Stereo, one of the NASA solar observing satellites, the Stereo satellite. So here it is, these bubbles of gas being blown off by energetic events on the surface of the sun. And they can head our way, but we can get good auroras even without a big flare, where we can get just holes in the corona through which there's more solar wind blowing out from the sun. And so we don't always need a major event, especially from more northern locations where you can get great displays even without some really massive flare going on. And so it is this solar wind blowing from the sun all the time that causes almost northern lights almost all the time from high latitudes. But when you get these bubbles, these coronal mass ejections coming our way, and we do get warnings now because of the NASA satellites and European satellites that indicate these and tell us, there, boom, we just got hit by one there. Sometimes they blow off from the sun and they don't intercept the Earth, as the first one or two of them does here, and they miss us. But when we get something like that hitting us, that's when the chances are higher of a great display of northern lights. Maybe. Depends on how the magnetic fields connect. So as the stuff streams from the sun, it intercepts our magnetic fields, which are like deflector shields. And the stream of solar wind, which has now got more energy because of some event on the sun, and it squeezes the field lines together in the tail of the Earth's magnetic field and imparts energy to the particles that are in the tail, and those particles rain down onto the night side of the Earth. Because obviously to see the northern lights, we have to have it at night. It has to be at night. And those particles that cause the aurora come from the night side of the Earth. They do not come from the sun, or even certainly directly from the sun. They are particles that are in the Earth's magnetic tail, which get energized by the flow of particles going past them. And they may snap the magnetic field lines together, increase that energy. It's like a particle accelerator, increases the energy of the particles that are in the fields already, and then projects them, propels them down the field lines where they intercept the Earth's atmosphere and start the air molecules and atoms in our atmosphere glowing. So here's kind of actual data from one of the NASA satellites showing you that it's a much messier process than the diagram just illustrated. Whereas the wind, it's like a windsock blowing in the wind, our tail, and you get these magnetic reconnections where the field lines are snapping together, maybe several times through a night, and you get outbursts of aurora coming and going through a night as it fades down and suddenly gets active again and dances and gets brighter and more energetic. So those magnetic reconnections can be happening all the time during a very active storm. The whole system is kind of analogous to, for those who remember, cathode ray tubes sitting in front of a picture tube to watch television, or on a computer monitor when they were the big cathode ray tubes. It's kind of similar to that, where you have a source of electrons, a very hot cathode in this case, but it's that magnetic reconnection area of the Earth's magnetic field. And then you have the shifting magnetic field lines, as I just showed you, moving the electrons around and painting them onto a phosphorescent screen in the case of a CRT, but painting them onto the screen of our atmosphere and causing the molecules of oxygen and molecules of nitrogen and atoms of oxygen to glow in the characteristic green and red colors we'll show you in a moment. So the atmosphere is like a phosphorus screen being scanned by electron beams created by this heated element and modulated by magnets. So that's kind of the analogy of what's going on. But the electrons that cause the northern lights don't come from the sun directly. There is a pathway, that's where they come from. That general area downwind, down in the tail, that's where the particles come from that then get beamed back down to the Earth on the night side of the Earth. There is a channel on the day side of the Earth here where particles can get into the Earth's atmosphere directly from the sun. And right here, and they can cause day-side auroras. There are auroras in the daytime. You can't see them in a daylit sky, but from certain locations like Svalbard, 80 degrees north, in December and January, the sun doesn't rise and it doesn't get light, and it's still dark, or at least twilight, all day long, and you can see daytime auroras, but they're very weak. They're not very bright because the particles coming directly from the sun, even during a major storm, do not have enough energy to really light up the atmosphere. It takes those sort of magnetic reconnection events in the Earth's magnetic tail to impart enough energy to the particles to really slam them into the Earth's atmosphere to cause the northern lights. So the auroral outbursts are caused by the flow of solar wind interacting with and adding energy to the particles already in the magnetic tail. There's all kinds of particles out there in space, but it's the solar wind particles are not actually the direct cause of the northern lights. It's these auroral particles. They are electrons, they are protons, but they have more energy than the solar wind particles coming directly from the sun. They have that energy because they've been energized by those reconnection events in the magnetic tail and other complex activity that goes on in the tail as well. And so in some cases, the aurora that we see at night are not necessarily caused by particles that have come just from the sun. They're caused by particles already in the magnetic tail. They may have come from the Earth originally or from the moon, but they are imparted more energy and get excited by the flow of solar wind past the magnetic tail of the Earth. So it's not really right to say, oh, the solar wind particles come flowing out from the sun, they enter the Earth's magnetic field and flow down and then cause the northern lights. Nah, it's not as simple as that. So how to know when to look? This is a view from Yellowknife, downtown Yellowknife, overlooking Frame Lake in the Prince of Wales Museum. There, how to know when to look. When should you go out, even if you're at a location where you can see the aurora, or if you want to plan a trip further north at all. This is kind of your typical auroral oval picture that's on spaceweather.com and many websites and apps and the like. And this is kind of your prime auroral oval. This is sort of standard. It's kind of always there. The red line is as far, that's where you have to be, at least as far north as that, to have any chance of seeing any kind of aurora on the horizon. It's fairly far north, but once again, from Churchill, Yellowknife, Alaska, you're maybe seeing aurora overhead, even at that kind of condition. So you'll see those kind of indicators at spaceweather.com. That's nothing very exciting unless you are right underneath the auroral oval itself, but that's now what you want to see when it lights up red like that, and the red alerts literally go out, and we're now heading up to KP 5 or 6 or 7 levels, and the aurora is moving south. So from those more northern locations, it's getting brighter, more active, but it's also moving south. Here's our red view line here. You can see now, as I showed you before, it's now heading down into the northern United States here, where they have a chance of seeing the northern lights from here, Minnesota, Wisconsin, but not over here, even in the Pacific Northwest, even though it's not much different in geographic latitude. So that's when it starts to get active, and if you're at one of those locations, that's when you definitely want to plan to get out of the city, get to a location where you can see the sky well and see the northern lights. So there's various Aurora apps. I like one called Aurora Forecast. It shows you that oval that's generated by the Space Weather Prediction Center that's associated with NOAA, I think it is. In fact, all these apps use the same data set from NOAA, just they display it differently. And it shows you, here's again the green kind of low-level aurora, but there it's picking up KP4, 5, or 6 here. That's what you want to see. It's looking more energetic. Here's Space Weather Live. It's a website and app, a little more technical. Gives you the current KP, the forecast KP, the BZ index as well, showing you it's south, but not too far south. And you look for that heading even farther south for an indication that it's going to get even more active that night. So Space Weather Live is another good indicator. Well, what to see in terms of the colors? People expect to see these vivid colors overhead or across in the sky, and you can see the colors, but it takes a very bright energetic display. And if you go farther north, that's your chances increase of seeing that. But it's the cameras. We're spoiled by the digital cameras that, gosh, as I'll show you at the end here, even your phones now can capture these colors very, very well, which your eyes can't, because your eyes have a limited exposure time. Even a phone camera can do an exposure of several seconds and pick up the colors much, much better than what your naked eye can. The colors are there, however. They're mostly from oxygen. The greens are from oxygen, and it's also the reds as well. But this now is more like what your eye might have seen on that kind of display. The camera with a few seconds picks up all the colors, but your eye is seeing a much weaker display. It's not even dark adapted. It's not sensitive enough. The rods in your eye are the most sensitive, but they're not sensitive to colors, only to black and white. And so it takes a very vivid display to excite the cones in your eye to see the colors. So you might see colors very subtly, perhaps, during a typical low-level display. Maybe just subtle. And it varies from person to person. I've been with groups of people where half of them are saying, yeah, I see colors, and the other half saying, I don't see any colors. So it depends a lot on the psychology and physiology of everybody's eyes as well. So people are often kind of disappointed that they're going to see those fluorescent displays with the eye. You can see the colors, but it takes a pretty bright display to do that. So the aurora colors come mostly from oxygen atoms. The green is the most prominent. Your eye is most sensitive to green, and it's typically brightest and most common. And the upper curtains can be red, deep red color. That's again oxygen, a different kind of atomic transition that's more rare. It only happens in the very, very highest part of the atmosphere where it's almost a true vacuum. You get the deep red colors. And then along the bottom is this pink fringe from nitrogen molecules as well. I'll show you a picture in a moment. But mostly it's oxygen producing the greens and reds that your eye sees, and your eye is seeing mostly the greens. In this case, there is a very faint red arc as well. That's a little different process called a stable auroral red arc that is not visible to the eye. That is something only the cameras really capture. But when the aurora gets bright during a very active display, those curtains take on a pink fringe as well, which really ripples and dances, as I showed you earlier on. And that's from molecular nitrogen. And it only gets excited and glows when the electrons have enough energy to get right down to the, well, not the bottom of the atmosphere. It's still 50 or 80 kilometers up, but into a denser part of the atmosphere, where the molecules of nitrogen can now light up, and there's more of them. But it takes a pretty energetic aurora to excite that part of the atmosphere, but it's still up very, very high. But you can see those with the eye when it gets bright. But it's the cameras that do pick up the colors, all the colors, very, very well. So any kind of camera will do the job when you go on an aurora chase. So how to capture the aurora? I do this almost every night. There is one out from my backyard. Although I shouldn't say that. Sometimes they're just such a low-level fuzzy display. It's not even worth it. Kind of go back to bed. Something that someone might get excited about from farther south. But when it gets really good, it's pretty amazing to capture. And these days, your phones can do it. You know, and Aurora tourists, they all have phones with them. Usually, they're easier to use than point and shoot cameras and the like. These are come specialized apps that I recommend for people with iPhones, Android apps. Usually the Android phones, the native image or camera app on Android phones is usually the best choice. But on the iPhone, there's these Northern Lights photo takers and nightcap and things like that that can take several exposures and stack them together in the phone. Just hold the camera very, very steady, and you can get a pretty decent, shot of the Northern Lights, enough to say you got a picture of it with just the camera you already got in your pocket and a $2 app or something. And so it works. They work pretty well. But if you really want to get a good shot of the Northern Lights, you use a camera that you might already have for astrophotography, a DSLR or a mirrorless camera now, almost more popular, DSLMs, and any lens but a wide angle, because when the Aurora gets going, you can't take it all in. You need a fisheye lens, like I show in the upper left, to really capture the whole sky. So you need as wide an angle as possible lens, and then very fast lens, as fast as you can get it, f1.4 to f2.8 as well, in order to capture the Northern Lights and freeze the motion, because when it gets bright, they're moving very rapidly. So you want to use short shutter speeds if you can, and a fast lens helps you do that. And the better the camera, the better the shots are going to be. So, again, that's what a lot of serious photographers will have in their kit anyway, but perhaps not the fast wide angle. When the Aurora is very faint, dim, slow Aurora, the exposures are 10 to 30 seconds. Again, f2 to f2.8, lens fairly wide open. ISO 1600 to 3200. Pretty high ISO, certainly by the standards of a few years ago. It's pretty standard now, and good cameras now have no problem getting great shots even at a higher ISOs than that. And so when the Aurora is faint and it's dim and it's not moving too quickly, a longer exposure isn't going to blur things too much. And when you want to do a time lapse, you can just take lots and lots of those pictures. And here, there's Steve appearing very briefly, just for about half an hour or so of the time lapse. And so we'll talk about Steve in a moment. But this is a fisheye shot that just happened to capture Steve in a brief appearance a few years ago. So you can do time lapse as well. If you can take one picture, you can take lots and lots with an intervalometer that just fires the camera every second. As soon as a picture is finished, you fire the shutter again and you just let it go for as many as you can. Now, when the Aurora gets very bright, however, especially if, say, the moon happens to be up, as it was for this shot, the exposures should be and can be much shorter. Only 1 to 4 seconds, perhaps. Still, a fast lens helps in order to keep the shutter speed short. And the ISO speeds can be quite a bit lower, 400 to 1600 tops, perhaps, to keep the noise down as well. And so a very bright Aurora is easy to capture with quite short shutter speeds. And you want to do that to freeze that rapid motion. And I like this picture because it was featured on a stamp issued by Canada Post a couple of years ago as well, one taken up in Churchill. So I'm kind of proud of that picture of the Northern Lights. And that was one frame out of a couple thousand I took that night of the Aurora in a rapid time lapse, just taking shots every couple of seconds, like a 2-second exposure, and as soon as one's finished, another one starts. And so rapid fire cadence time lapse, and then strung together and slightly blurred together. It's sped up, it's time lapse, but it gives you a better idea of the motion, the flow of the Northern Lights. So it's not too unlike what you would have seen with the eye, had you been there as well. So rapid fire time lapses are kind of neat way of capturing the Northern Lights as well. But the camera's got to work in the cold for an hour or two. What cameras can do now, particularly the mirrorless cameras, DSLRs not so much, but mirrorless cameras. This is the Sony a7 III. I have the Canon R6 now, which is about as good as the Sony cameras are for doing Northern Lights real-time movies, 4K movies as well, but ISO 12,000 to 51,000 or so. But in a movie, it's kind of tolerable. The noise and everything is fine, and now you capture the actual motion, what your eye actually did see and could see as well. So you can now do these real-time 4K movies. What was unheard of 5 years ago, certainly 10, 12 years ago, you needed tens of thousands of dollars special cameras to do this. Now any camera, well, not any camera, a good DSLM camera, mirrorless camera that you can buy off the shelf will do it. But a fast lens is still key. Very fast lens is still key. Well, just to finish off here, talk about one of the unusual forms of aurora called Steve that you may have heard about and kind of discovered here in my area. He's often seen in my area. In fact, here he is over my house earlier on this year, I think it was, in a brief display. It's kind of an anomalous arc that's been seen for decades, centuries, but only kind of recently identified as a unique phenomena worthy of separate study. Because of photographs taken by amateur astronomers, photographers like myself, saying, look, I've captured something unusual here. What is this? Pointing it out to the professional researchers, they say, we don't know. What is it? And it's now called strong thermal emission velocity enhancement. That's what Steve means, but it's a backronym. Because when it was first kind of identified as a unique phenomena a few years ago by amateur photographers in my area here with the Alberta Aurora Chasers Facebook group, people were saying, oh, it's a proton arc. Look, I captured a picture of a proton arc. And the professionals said, no, that's not. It's not a proton arc. That's not what a proton arc is. It's a misnomer. It's don't use that term. So the suggestion was, well, from the leader, in fact, of the Alberta Aurora Chasers group, Chris Ratzlaff, let's call it Steve, because it's a name the characters in the movie Over the Hedge, a Disney movie, gave to some mysterious thing that lived on the opposite side of the hedge. They didn't know what it was. It was mysterious. It was a little scary. Let's call it Steve to make it more friendly. And that's Chris suggested, well, we just call it Steve. And it got acronymed to strong thermal velocity, emission velocity enhancement, because Steve is not an aurora per se. It's not caused by aurora particles raining down, causing these curtains, vertical curtains. It's caused by electrons flowing east to west. And very hot electrons, several thousand degrees, quite high up. Higher than the sort of brightest part of the aurora, 250 to 300 kilometers altitude. And those numbers have come from amateur photographs, including one like this, one I submitted here to one of the papers, where people triangulated. We're all out around Alberta taking pictures of the same Steve, and so the professionals can use parallax to triangulate where it was in the sky in terms of high altitude, what the altitude was. So amateur photographers have been very instrumental at not only drawing this attention of professional astronomers to this phenomena, but contributing data, contributing photographs used to study it as well. So exactly what's causing this hot gas flowing from east to west, we can see it with our eye moving from east to west, is still a matter of ongoing research from NASA satellites and from ground-based research as well. It takes on different forms. Here is a very thin, emaciated Steve across the sky as well, but he's always south of the main auroral oval. And it's always after a big storm. We get a bright display, it subsides, it heads back to the north, and then you watch and you wait, because that's when Steve's going to appear. And that's often the case. It was the other night as well. It didn't appear until quite a bit later, but it's often always after a major outbreak. There's something that's setting up these hot flows of hot gas and causing them to go from east to west after a major outbreak of northern lights. So a fascinating phenomena. There's another phenomena associated with Steve called these picket fence fingers, where there's little green fingers that flow along as well and that ripple along the sky, and those do seem to be more normal electrons raining down. It's a complex phenomena. No one's really figured it all out yet. Here's a classic Steve here. So it's quite amazing that for something that cultures have seen for thousands of years and told stories and myths and legends about, and for all the modern research and capabilities we have today, what's going on above our heads is still somewhat of a mystery. And it's an amazing story that amateur astronomers have contributed and are contributing some major areas of to this area of research and contributing our pictures. The professional researchers are very much interested in getting our photographs here. Here's one from a couple of nights ago where is this a Steve? It's hard to say. What is this? Is it a SAR arc, this stable auroral red arc? Maybe that's what I thought it was, but it may not be, because it looks like it's got kind of radial structures going up and down vertically. What is this? So there's all these odd auroral phenomena, which the digital cameras are now capable of capturing, and that's been the revolution. And so it's opened the eyes to professional researchers to study and learn more about what's going on just 300 kilometers above our heads. It's an amazing story. And so there's lots of great science associated, but the bucket list experience is just standing out there, whether it's the cold or whatever it is, and heading up to see the northern lights and watching this display. Because when it gets active, it's just hard to imagine what nature is capable of doing and how the sky can burst open like that with these incredible displays of motion and color. And you really want to check that off your bucket list. Like seeing a total eclipse of the sun, which hopefully you saw in 2017 and will again in 2024. You want to see the northern lights. And just like total eclipses, you got to chase. You can't wait for it to come to you. I have that fortune down here. I can do that. But anywhere else in the US, you pretty well have to head north, up to Alaska or up to northern Canada or Norway, Scandinavia, or Iceland as well. So I hope you will do that and chase the northern lights. So it's my pleasure to speak to you this evening. We hope you enjoyed the presentation. My name's Alan Dyer. That's where you can reach me at amazingsky.com is my website, and I am the co-author with Terence Dickinson, The Backyard Astronomer's Guide. Brand new edition just out this year. In fact, this autumn came out in September and October this year, hitting all the bookshelves and bookstores and retail outlets as our new, greatly, hugely revised 4th edition of the Backyard Astronomer's Guide. And so I thank you very much for your attention this evening, and perhaps we'll be able to go live now for some Q&A. Thank you very much. All right. Well, we're back live, not Memorex. There, I can see that talk was a little older than I thought. So, but anyway, it did cover all the material is still current there. So, if you've got, I guess, any questions here, begin chatting a little bit here in the chat room. If you've got any other questions. Now's the time, and fire them my way while I'm back live here.
I just wanted to make a comment, Alan. We lived on the Alaska Highway for 12 years in Fort Nelson and Whitehorse. And Whitehorse, this is pre-DSLR days, so we would do imaging with film. And we'd go out to Fish Lake, south of Whitehorse, and get all set up and everything's going. And then everybody would throw their hands up. The Aurora's here. And we shut down everything and take it back into town because you can't image during the Aurora. But there's something interesting about Auroras and Japanese tourists. In Japan, it's considered very lucky if you conceive a child under the northern lights. So in the winter, we would have plane loads of Japanese tourists, and I'll leave this imagery to you, going up onto the mountains around Whitehorse to conceive children under the northern lights. It was cold.
Rick, I'm gonna tell you that's another popular misconception. You know where that myth came from about the
Well, we
Japanese?
were there.
Oh, they're there because there's Korean, there's Chinese now, there's tourists from all over the world, German, whatever. Why are they interested in Northern Lights? Because the Northern Lights are wonderful.
They are. They're incredible.
The myth of the Japanese couples wanting to conceive of Northern Lights, where that came from, is a TV show that you might remember called Northern Exposure. and it was about a northern town. And so they were trying to explain the tourist visits or whatever. And the screenwriter has admitted he just made it up.
Oh, Lord. And it made it
just
through
made
the
it up.
Japanese culture.
No, it's not in Japanese culture. It may be now in Japanese culture because they don't even realize that it's a myth about a myth. And so, no, they don't. They don't. And so they come because they simply want to see the Northern Lights, just like everybody else. That's all. And not to say that they may now think it, but but that's where it came from. It's a myth about a myth. And so anyway, yeah, the screenwriter just made it up.
Now I've got a picture of Hail Bob. Now I wish I had taken it, but I didn't take it. It's hanging on my wall, but I bought it. It's Hail Bob in the Northern Lights, framed by trees, taken from Fort Nelson, BC, and just an incredible picture. And I remember one night in Fort Nelson, I stepped out of the airport to do the hourly weather ob and looked up, and the Northern Lights were strong, and they were red and green and purple. It was just incredible. So that's where you want to go, folks. Get up onto the Alaska Highway when it's going to be dark at night and enjoy it. So I'll turn it over to anybody else who has questions.
Yeah, funny you should mention that, Rick. I have a picture. I tried to find it because it's obviously on slide, and I thought I'd scanned it or whatever. April 10th, I think it was, 1997, Hail Bob. There was an occultation of Aldebaran by the moon. There was Aurora, and there was Steve. We didn't know it at the time, Steve, but there was this arc like that in the sky as well. So what a circus that night in the sky. It was
You ticked all the boxes.
Just one of those amazing nights, because we've been shooting and photographing, seeing this thing that we now call Steve for a long time, this anomalous arc across the sky. In the Okanagan, I remember Ken Hewitt-White drawing my attention to it, and we looked it up when I was out there giving a talk to the Okanagan Astronomy Club, the Okanagan Center, the RASC. We were looking it up in the historical records, and there's this kind of local lore about this Okanagan arc across, thinking that only they see it, but of course it's seen all across Western Canada. So they've been seeing it for decades, this isolated gray arc, which to the eye again doesn't have a lot of color. That's what is it? It looks like a aircraft contrail or something. And so it's been cited for decades, but only since about 2016 is it identified as a unique scientific phenomenon and given a name, and lots of people studying it. And since I recorded that talk, in fact, one of the last pictures I showed was used in a scientific paper about the green stuff was proton blobs, protons causing the sky to flicker off and on. And then the red SAR arc, which is probably not a SAR arc, and yet another type of anomalous arc that's been identified as well because of amateur pictures, because our pictures are better than what a lot of the professional all-sky cameras, which are recording the sky all the time, but they're low resolution. And we can get better resolution and 4K, even 8K movies now as well that they can make use of to study the Steve and the Northern Lights. It's got an amazing story of this amalgamation of pro-am science. We know that is the case in amateur astronomy, the variable stars and all kinds of other extrasolar planets now. But the Aurora is a very good case of where we as amateurs can contribute. In fact, professionals almost kind of depend upon our pictures for certain parts of the research. the satellite data and other geomagnetic instruments and whatnot as well. But we contribute a lot to this research in the upper atmosphere research field. Any other questions? I see Blake asking about dark frames. No, I don't bother taking dark frames for if it's up in Churchill, your camera's at minus 30 degrees. It's cold. There's no thermal noise. But no, because with the Aurora, you don't want any gaps in time. You want to take pictures rapidly if you're doing a time lapse or whatever, because it can be changing quite quickly. So I don't bother taking dark frames or anything like that for northern lights at all. Just because your exposures are quite short. You're not going many minutes like for the deep sky photography. So
I have a question, Alan.
Yeah, Peter, go ahead.
So I don't think you've ever lived in Southern Ontario, have you?
No.
So as I've heard a million times, because of course we've got lots of population in Southern Ontario, the seeing a really good aurora display down here is quite rare. And in fact, there's already been a couple of folks post comments that, in the last 30, 35 years that, I've been an adult with an awareness of what's going on in astronomy. We've seen a handful tops of, really good displays in Southern Ontario. But what I want to know about is the patchiness of them. When I hear people describe the aurora, even your pictures, you get a sense that this auroral arc is a complete arc. It goes all the way from wherever the heck it is up in Alaska, loops down to the south, and then curls back up to wherever it is, Newfoundland or Iceland or something like that. And in Southern Ontario, the sense that I have from the handful of experiences that we've seen here is that it's very patchy. You can go out and not see the aurora and then go out 5 minutes later and it's beautiful. Now, it seems to me that if there's an auroral arc, there should either be an arc or not an arc. And this idea of patchiness kind of confuses me. Do you know what I'm talking about? Can you explain that? Is there a reason?
For one thing is that the auroral arc can move south, and yes, there's a continuous arc perhaps, but yeah, there can be sections and fragments of it where particles are entering the atmosphere in different spots around the Earth. It's not a always continuous band. And so when you have a substorm underway where suddenly the level and intensity of incoming particles goes way up, it might be just in one geographic area, east or west or whatever, and then it flows across. I mean, we see that all the time, even from my backyard, and certainly from Churchill, where you'll see it brighten from the east and then start to flow across and then come over you, or then go to the south. And I've seen arcs just light up, just suddenly where there was no aurora, suddenly overhead there's an aurora, and then appears to the south, where the particles now suddenly start to light up the atmosphere. So that can certainly happen. The other thing is, south of the main aurora, there's often patchy aurora bits flashing off and on, especially post-substorm, after a really bright classic auroral oval arc is lit up. South of the main aurora, you see patches pulsing off and on. If you look at the pictures of the northern lights or the southern lights from the space station, as they're seeing now the big picture, you'll often see to the north the classic arc, and then to the south you're seeing patchy bits flashing off and on. And that's often what we might see, or what you might see over you, whereas the main aurora is still to the north. And those patchy bits pulsing off and on are caused by electrons trapped in the magnetic field that are bouncing back and forth from the north to the south magnetic poles. And they're just coming in, bam, hitting the atmosphere and bouncing back, and doing the same thing in the southern hemisphere as well. So it's a different kind of process. It's not incoming particles, new particles coming in. It's stuff that's trapped in the inner Van Allen belts going back and forth that usually may not hit the atmosphere, but sometimes they'll come right down and cause the atmosphere to literally just turn off and on. It's a really strange phenomenon. And it's it's Aurora, but it's a little bit different process than the classic arc.
So let me follow up with two things then. You know, in your experience in the higher latitudes, does the same thing happen, or are you used to seeing basically when there's an aurora, you see the whole arc, or else you don't see an aurora at all? That's the first
higher latitudes, you generally see more just the classic arcs. I have, in fact, the first time I saw this patchy pulsing aurora was when was I in Churchill? Last March, I think I was last in Churchill. And that was the first time, and I've been going up there since 2014. And the first time I saw this patchy aurora, which was unusual. I hadn't seen it before. Not to say it doesn't happen, just I hadn't seen it before. And it was kind of odd because that very week they were launching rockets into the atmosphere from the Alaska rocket range to study that exact phenomena, this patchy stuff as well. So I was kind of reading it in the news and putting it into my talks to the group that night, and there it was. So these auroras can take all these different forms, and Steve is one of them. And now this red SAR arc is something that's been known about for a while, and now they think there's something kind of a hybrid. And one of the classic shots that I want to try to get, there's very rare occurrences of a red SAR arc turning into Steve, showing the clear relationship, but exactly how, and that's something I'm after as well. That's kind of the holy grail, to get this whole process of a red subvisual SAR arc suddenly turning into Steve and turning and going visual.
Yeah, that sounds really interesting too. But I wanted to pursue the thing about the patchiness of the aurora at the latitudes that we're at. For one more question or thought about that is that I think that for the large population that you have in that range of latitude, you know, Toronto, Montreal, Chicago, those, all of us down here, I think it ends up being it fosters the misconception that the aurora is predictable the way a comet is predictable, or even the way a meteor shower is predictable. So, you know, I've had lots of non-astronomers, non-technical folks, you know, who have an interest in nature, an interest in beautiful things, interest in science a little bit, but not any education. And they'll say to me, oh, they saw a headline in the newspaper that there's going to be an aurora tonight, and they want to know, should they go see it? Or worse, they'll come to me the next morning and they'll say they saw a prediction that there was going to be an aurora. They went out to look for it and they didn't see it, and now they're upset. Why couldn't the scientists tell? So I'm not saying that, I'm not sure if we can fix this, but I think the idea is that we should try and promote an awareness that at these latitudes, the aurora is not an on-off sort of a thing. It can be patchy. And I've told most of the folks who ask me about it that if there's an aurora prediction, it's not a definite prediction, it's a possibility, and they shouldn't.
The same is true. The same is true right here, Peter, not just Southern Ontario. Southern Ontario, you've got to get up to KP 6 or 7, and it may get that. For here to see this is KP 4 or 5, but there can be predictions for a high KP, and nothing happens. As I said in the talk, the BZ doesn't go south, nothing connects, and it fizzles. And the local rule around here is the higher the media hype about an aurora, the less likely it's going to be actually turn out to be a good aurora. And the best auroras are ones that suddenly, whoa, wasn't expecting that. And so, you know, it's like media hype about a green comet shooting across the sky every 50,000 years. Oh, we're going to go out tonight and see that. No, you're not. Right. And so it's the same with the Northern Lights. Sometimes it does happen where, you know, all the indicators show a great display is going to happen, and it does. But for Southern Ontario, even in Northern US, it's got to be a pretty high KP. All the numbers have to come together to make it happen. And even then, you just might see a glow to the north. And why do people say, gee, I remember seeing the Northern Lights so much more often when I was a kid? Yeah, 40 years ago, there were no streetlights. you live in the city now. You're not going to see it. And people still are not aware of the fact that, how much of the night sky you've lost, even the last 10 years.
Yeah, I grew up in a right. I grew up in a suburb in southern Ontario, and never saw the aurora as a youngster, but not because it maybe, I don't know if it ever happened in those 1960s, but the thing was that I just didn't look at the sky. There were so many street lights and so on. I mean, I thought astronomy was something you got out of a book. I didn't really think of astronomy as something you could do live. So it would never have occurred to me to look for aurora in suburban Niagara Falls, Ontario. So I'm not sure if we want to switch. You mentioned Steve again just a moment in one of your answers there. But I think Dale should chime in on this, because Dale and I saw a display of Steve from our Fingal observing site southwest of London back in around 2016 or 2017. Dale might even have the date. Just not long after it was, kind of brought out and promoted as a separate thing. And we were really kind of surprised that we would see it, just basically almost the first time we were given an opportunity to look for it. I'm not sure if Dale's listening, but
I'm listening. I don't remember. I was out there with Ian Franklin when there was a Steve, but I actually don't remember observing one with you, Peter. Yeah, you're right about the date. So maybe you saw it from a different location is what I might be guessing. And that picture I took ended up in Sky News because they published all of the pictures from across the country of what was a really tremendous auroral display. And speaking to Alan's point about how after like a really big surge, then the Steve can come afterwards further south. And I would say that was what happened that particular night. And I think that's also what happened with Patrick, who saw one, I think it was last summer, and put the pictures up on our forums.
Yeah, because Steve is farther south than the main auroral oval, people further south have a better chance of seeing it. But it does take, it appears at least a KP5 to trigger a Steve to occur. That's still a little uncertain what the circumstances are necessary for Steve to appear. But Steve typically only lasts half an hour, so you got to be lucky to see it. And you might see it as a gray band across the sky and not think anything of it. Just what is it? Especially if the moon's up, you might not see it at all. And so it people can see it and just not even be aware and not pay attention to it because it doesn't look like a normal aurora. So, but it typically always happens on the downturn after the substorm subsides. That's when we know to start looking for Steve, and it appears in the east first and then gradually works its way across the sky and can be all the way across the sky and then take on the green picket fence fingers as well, which have a slow motion actually not that slow, fairly fast motion across the sky, rippling motion as well, and very fine structures in that. So it's pretty amazing, but it is kind of prime territory in Western Canada because we're south of the main auroral oval typically. So Steve comes right over top of us, but in a very more active display, he'll be further south into the northern US and southern Ontario, certainly. And the more displays that, if you see displays like that and capture them, report them. Whatever, your local Aurora Chasers Facebook group or whatever, because scientists want to compile the statistics of when it appeared, where it was seen as well. And so, make it known that you saw Steve, or here's my picture. Sometimes people post pictures of what they think is Steve and it's not, whatever, it's just a bit of a auroral arc or something, and it can be a little bit odd. I even question whether this was a Steve or not, but apparently I think it was this night. But that's the normal aurora here. Here's more Steve.
Follow-up question, Alan. First, I want to just say that was just a stunning presentation. Seeing your pictures and some of those videos just blew me away. It's hard to believe how good the aurora can actually get. The second thing I wanted to say is you mentioned the Canon R6 is as good as the Sony's now, but I also noted in the latest edition of Backyard Astronomer's Guide, you shy away a bit from the Sony's because of some kind of glow that they're producing when used for astrophotography. And then based on that, the next part of that, I wanted to ask you, how are the Nikon Z6, Z7s comparing to the R6 for this kind of work?
Everybody wants to know, what's the best camera? The Sony A7 III I used a lot for Aurora movies. I did find it had some amp glow, but then that got fixed in a software firmware update, from what I understand. And I don't have the Sony anymore. I've kind of gone strictly to Canon. And one reason is that the Canon R6 does a very good job on real-time movies as well. And this is kind of one of my favorite Aurora lenses, the Laowa Venus Optics 15mm f2, so wide and fast. And I like this lens. I had it for the Sony, and I rebought it for the Canon system as well. And so they can all do a very good job. The Sonys had that amp glow, didn't affect Auroras or anything. But deep sky stuff, I could see it on deep sky shots with the Sony. But again, I think Sony fixed that with a firmware update. And the Nikons are equally good. I've only tested the Z6 when it first came out, and I think it was a test report in the Sky Telescope. Very good. And you're hard pressed now to get a bad camera. They're all very, very good cameras. But it's low light video. If you want to take the real-time movies of the Northern Lights, there's cameras that are better for that, and the lower megapixel cameras are better. The Sony A7S series is the champ for that. They're only 12 megapixel, but they're really low light sensitive. And then a lot of the real-time movies you'll see of the Northern Lights have been taken with that series of cameras that are made for low light video. But the Canon R6 does a pretty good job for at ISO 50,000 or 100,000. That's what you're shooting at for real-time movies.
Thank you.
I've got a question for you.
Yep.
So you're going up to Churchill or Yellowknife. What's your method of transportation? You're not going in the best of weather usually, right? So you're kind of going up in the snow. I know there's a train goes to Churchill to go see the polar bears.
The train to Churchill does run year round. And that's an option via rail. It's a via rail. It goes through Thompson, Winnipeg, Thompson, up to Churchill. It's a 2-day trip. A lot of tourists like to take it for the adventure. I've never taken it. In fact, just today, I got my flight confirmations from the Churchill Northern Study Center for my flights next month to go to Churchill to teach 2 Aurora groups in February, last 2 weeks of February. And that's calm air. You fly from Winnipeg to Churchill. There's 1 flight a day up and down, I think it is, either direct or through Gillam on calm air. It's the only airline that, other than charters, which some of the big Aurora tour companies just charter plane, way to get to Churchill, because you can't drive to Churchill. Yellowknife you can drive to if it's a long drive. You can't, but there's lots of flights to Yellowknife from Edmonton, Calgary, Vancouver, 2 or 3 a day, or 3 or 4 a day. Once you're there, however, in Yellowknife, you go in midwinter, you got to rent a car, and now you're driving out of town at -30 or something. I haven't done that. I go in September, we rent a car, and it's only freezing, or at worst -5 or something. It's very bearable. In Churchill, we go to the Northern Study Center, where we live, stay, sleep, eat, learn, right at the buildings I showed in the picture. So we were picked up at the airport, taken out the study center. We do day trips around town and whatever, and dog sledding and things like that. But all the Aurora viewings down at the study center, right around the building. There's a heated dome. You can go up and watch the Aurora in your fuzzy slippers and pajamas if you want. Things like that. So,
that's open to the public?
Yes, not to walk in, but you have to register for sessions. Just go to churchillscience.ca, and I think they may still be taking spots and slots open for March, not for February when I'm there, but for March, I think. I'm not sure this year, but I think they may even have next year's dates on there for the Aurora. February, March is typically, and it's a 5-night program there, which includes lots of daytime activities, plus the talks that myself or Ron Waldron's the other fellow RASC member from Saskatoon, that we split the responsibilities, and he does 1 month, I do the other month. So it's a very nice setup. I mean, it's just so convenient. You put on as much stuff as you want and get outside, or
Right.
and then when you're done, you just go to bed.
Right.
and there's hot chocolate and fresh cookies on whatever. It's great.
We all know what it's like trying to observe in the wintertime. I used to have electric socks and coal burning things in my pockets.
I just ordered a new electric vest from one of the local companies here. I got my electric gloves.
Yep.
But you, unless you lived in the north, you don't know what cold weather observing is like until you're minus 35 or minus 30 in Churchill or Yellowknife or whatever. With the wind chill, you're down to minus 50. Something like that. And but we can get out of the wind and where we are in Churchill, and but going out in Yellowknife, just out down the Ingraham Trail at minus 30 or minus 40 in a car, on your own.
Yeah.
There's buses and tours that will pick you up and take you out to lodges and things like that.
I see. Right.
Better way to do it, probably.
Oh, thank you.
Don't go out in your pajamas.
So those are the two main places. There's Whitehorse and Yukon as well. Tends to be a lot cloudier from what I understand from people that I know have been there. But it obviously can be wonderful displays there and great scenery. But because they have the mountains there, it can be a little more unpredictable in the weather. But Whitehorse is the other spot in Canada that's quite popular, that gears to tourists. And again, lots of foreign tourists coming in as well, and to Alaska. But Yellowknife and Churchill are the two main spots in Canada underneath the auroral oval. It'd be great for northern Quebec, but it's not exactly
There's nothing up there.
Geared to tourism up in Nunavik, northern
Right.
Quebec, or even Labrador.
There's nothing there. There's nowhere to go.
Well,
Happy
the people who
Valley
live
State.
there would disagree with you, but
Yeah, I know.
If you live there, there's lots to do.
Yeah, I don't know. I lived in Cambridge Bay for 5 years. There's not lots to do.
Yeah, it's interesting. We have some members in the Aurora Chasers group, who live way up in the Arctic, whatever Arctic communities, and they're seeing Aurora to the south, and maybe unusually. I mean, not often. And when they do, it's to the south of them, from well above the normal location of the auroral oval. And Cambridge Bay is one of those places where you might actually be able to see the dayside auroras, but I've not heard of any reports from there. Where
Yes, during the winter.
During the wintertime, you might be able to see dayside auroras, but the primary location for dayside auroras is Svalbard, 80 degrees north latitude. There's a research observatory in Svalbard just for the dayside auroras there.